Welcome once again. Now to be discussing about the fuses and the power distribution for each system. Sometimes when you look at these type of schematics, you see a lot of lines, and it's very intimidating and it's very confusing. So sometimes you have fuses all over the places. You're not sure how it interacts with everything else. So the easiest thing to do is, especially for beginners, like I said one time, like I said, this is Honda Accord, one of the most popular cars in the world, and the most durable and the most reliable. Now, this is the power distribution. It gives you a block diagram of all the fuses and the systems that it's connected to. So it's a little easier to understand. So here is a good place to start from the top. Usually I say pick a point and then continue going up. Here, you can start from the top if it's more easier to understand. So let's say we're looking for the radiator fan relay, which is over here. Okay? This is the pin. This is a connector. This is the pin number 2 that it's connected to on the relay. Now, if you notice, if we come back over here, it goes back to the battery. Now, the battery obviously goes through a white wire. See this? Through the starter. So one thick wire, you see this is thicker than this. That means it carries more amps. You see this one over here that goes to the battery is thicker. It's black. They're both over here, white and white, but this is thicker because this carries the current, most of the current, to the fuse panel, which is distributed all over the place. And then you see that harness that comes out like 20, whatever, 30 wires, whatever, multicolored. That's what's happening. This main feed, I call this the main feed from the battery itself. It could be red, it could be any color. In this case, for Honda, it's white or black yellow. White, usually one color, white. And it goes to this point over here, the splice. And then it gets distributed. That current flows all over each individual system. So we were dealing with, let's say we had a problem with radiator fan relay. The radiator fan is not turning. We're overheating. First indication of overheating is, besides the coolant, is the fans are not turning, especially in idle conditions where you're not pulling in any air, right? So therefore, you're going to overheat pretty quickly. If you're driving highway mileage and you're cruising, you already have air being drawn in into the engine to cool it off. So idle conditions, let's say you're in traffic and you're waiting, have a problem. I don't hear the fans coming on. It's an electric fan, transverse engines. So anyway, this one goes over here through this. Notice this, and what I'm trying to pay attention to is the ratings. Pay always attention to the ratings of the fuses. The higher the rating of the fuse, the quicker it will drain out the battery. So if you come overnight, let's say you left your car, you finished work, you shut off your car, right? Obviously some cars will give you chimes if you leave the lights on or whatever, or something like that, or if you leave the key on, obviously, but it's called a tone generator that gives a chime, a tone. It will indicate to you, hey, you forgot the lights on or something, or the key or whatever, right? So if you have, let's say if you don't have that accessory to tell you that. Let's say you forget the lights on. You don't pay attention. Those lights can draw about 20 amps. Those are high current. That will drain your battery. When you come the next morning, your battery voltage could be about 10.5, 10.6, maybe 11 volts. That's a quick drainer. So what are we trying to say here? Radiator fan is not working. What's the fuse number? Fuse number 11. How many amps is this fuse? Now, here's where it gets a little complicated. You see 2 ratings over here. Now, there are many models for Accords. 2.4 liter and a 3.0 liter. Whichever one you have, if you have the 4-cylinder or 6-cylinder, whatever you have, if you have a 2.4 liter, you're looking at this number, the first one, 20 amps. If you have the 3.0 liter, you're looking at the second one, 30 amps, even more. So, in other words, the bigger the engine, the more amps, the more you need the fan to cool it off. The main feed over here is 100 amps. This 100 amps is distributed all over. 100 amps, whatever. Could be 30 amps over here, could be 20 amps, could be another 20 amps here, whatever. Whenever they're working, they're working. So therefore, this is a multi-fuse. This is an important one because this has problems usually with these types of vehicles that can blow. So if I have 12 volts over here and I have 0 volts over here, you guessed it, this is blown. But why is it blown? You have to see why. I made a video how to check for shorts, because obviously you're not going to go and put another fuse. And I made this video how to check these things. You never put another fuse when a fuse is blown. And 100% of the mechanics do that. You do not do that. With disrespect to ground, from here, this point, to ground, on an ohm meter, you put on ohms, like I did in the video. Go look for it on my channel. You measure, make sure you don't have a short. Because if you have a short and I put another new fuse in there, you're going to have the same result. You just blew 2 fuses. No reason to keep on putting fuses without the measurement of an ohm meter from here to ground. On any one of these, from here to ground, from here to ground, from here to ground, here to ground. Why? How do I know which side is ground will go to the load? Put on volts. We said the fuse is blown, didn't we? That means one side will have 12 volts. How much will the other side have? 0 volts, right? 0 volts, that's a side that you should measure ohms to ground with, respect to ground. So you leave the negative one on ground. You go to the other side of the fuse, the one that was blown. You put an ohm meter, very low reading, and you make sure you don't have a short before you put a new one. 100% of the mechanics will put a new one. They don't care. That's not how we teach this channel. We teach this channel to be open-minded, and also how to diagnose correctly. What they do is not diagnose it correctly. It's just a quick fix that they hope that the fuse will fix the problem. So 100 amps here. Now look at this. 40 amps here. 40 amps goes over here. Let's look at these. Like I said, notice ignition coil relay. Look at this. Draws 40 amps. Right? 20 amps for this condenser fan. For the rear window defogger, look at this. 40 amps. That's a lot. Look for the blower motor relay. 40 amps. That's a lot, isn't it? So therefore, look at this one. AC compressor clutch relay. Only 7.5 amps. It's less than 8 amps. This does not draw that much. So pay attention to all these ratings. The one with the highest one sometimes gives you the problems. Ignition coil relay. What does this signify? These are the pin numbers. 15 amps here, as you can see. This is 40 amps. But this 40 amps over here, look, is divided here, here, and here. So 40 amps will not be all of this. This will be 15 amps. In order to blow this one, you have to have more than 15 amps. In order to blow this one, you need more than 40 amps. So therefore, first you go, these are pins 1 and pin 4 of the relay. This is pin 19 of this MICU computer module. This is a sensor. A sensor takes 15 amps. How do you like that? Okay? So this is basically how you look at it. Always look at the system, and it gives you the pin numbers, the relays, and it gives you the ratings. Make sure to pay attention to the ratings, as you can see. So all this is in a fuse box on the hood, fuse relay box. This is one fuse box. This is another box. See the dotted line around it? That means all the fuses, whatever you see in this dotted line, the relay, this module, whatever, and this sensor relay, and all this is contained in this fuse relay, which is next to the kickstand, next to the dashboard, next to the steering wheel, underneath it. And this is on top by the engine. That's what it signifies. So pay attention to these things. Like I said, whenever you see these things, 2.4 liter, 3.0 liter, that means this one on top is for the 2.4 liter. This one on the bottom is for 40 amps, 3.0 liter. Like we said, the more cylinders you're going to have, the more amps you're going to draw. Okay, go to my channel, Joe Electronic Schematics for Auto, and my other one, Automotive Electronic Schematics by Joseph, and you'll see many videos, hopefully on hands-on, if you don't see them now. Thanks.